Okay, students, now we are going to start with some more questions. As we have ended the chapter, we are going to do the questions so that how to apply the concept. In organic, main problem is that learning concept is easy, but which concept is to be applied at what condition, that is only the main problem. Okay, so they are not in paragraph, they are in equation only. So if you able to understand approach, then it will be easy for you to organic. Okay, so that's why now we will focus more on the question, and I will tell you which word is meant for what, so that which approach you should make. Okay, let's start. Okay, here is the first question. During dehydration of alcohol to alkene by heating with concentrated sulfuric acid. Okay, the chain initiation step is, first option is formation of carbocation. Formation of carbocation is, this is the first step. Our second step is elimination of water. Second step is elimination of water. Our third step is formation of ester. Formation of ester. Okay. Fourth is protonation of alcohol. Protonation of alcohol. These are the steps heading given. You have to find out. Okay. These are the steps given, and you have to find out which step is the chain initiation step. In the normally mechanism, there will be three steps: chain initiation step, chain propagation step, and chain termination step. Okay, think and answer. Okay, the main dehydration of alcohol is done by using the acidic medium, especially sulfuric acid, concentrated sulfuric acid. Why it is used along with the reasoning I am explaining here. See, H plus, acid provide H plus. The main problem of the OH is leaving tendency. What tendency? Leaving tendency of OH is less. So to improve the leaving tendency, it is protonated. The chain initiation step, this proton comes from the H2SO4 and it gets attached here. Okay. Now the leaving tendency, excellent leaving group. Water is a excellent group, leaving group like nitrogen. N2 is also excellent leaving group. Here to make it excellent leaving group, protonation was necessary. This is a, but that clearly in organic every word is to be clearly understood. Chain initiation. Okay. So when when this question came in the examination, most of them replied as a minus H2O. Okay, but it will take place after that, and in that step product is carbocation. Okay, so if the result question is asked what is the reaction intermediate in dehydration of alcohol, what you will write? Carbocation. So whenever carbocation is there, there is a hydrate shift, methyl shift, and phenyl shift is possible. Okay. Now, this H plus was provided by acid, so it is to be returned back. So that return back will be done in the final step, H and this plus. So this will be converted into double bond. Finally, what you will get? Alkene. Okay. Initially, we were having alcohol. Finally, it is converted into alkene. This is the conversion of alcohol to alkene by using acidic medium such as sulfuric acid. Okay. First question and all the details related to it. All these questions are taken out from the ABHYAS app. There is an ABHYAS app launched by the NTA. Okay, and there are questions, and I have segregated all the chapter-wise questions. So I am discussing the ABHYAS app questions and chapter-wise questions, so that it will be easy for you to understand the concept and apply them. Okay. Okay, here is the next beautiful question. The best reagent to convert pent 3 into ol into pent 3 in 2 is, okay. Option A is pyridinium. What is the option A? Pyridinium chlorochromate. Chlorochromate. First option is chlorochromate. Okay. Second option is chromic anhydride. What is the second option? Chromic anhydride. Okay. In glacial, that glacial word is very important. I think all of you are aware it. Glacial acetic acid. Okay, glacial acetic acid. The word importance of glacial acetic acid you should know. Okay, a acidic dichromate. Acidic dichromate. C option is acidic dichromate. Okay, then fourth option is acidic permanganate. Acidic permanganate. Okay, these are the four options. We wanted to convert pent 3 into ol, and it is to be converted into pent 3 in 2-one. Okay, this is in the preparation of ketone as well as in the properties of alcohols, two chapters. Okay, so if they will be perfect when, because as if you have studied both the chapters. Okay, try it. Okay, now listen carefully. The question twist is here. 3 in and 3 in. Understood? So without disturbing during the reaction, oxidation of alkene should not be there. Understood? Without disturbing the double bond, alcohol is to be oxidized only up to the ketone. Only up to the ketone. Okay. So generally when this question came, potassium permanganate, this is the option gained by most of the students. But the main problem is that it is a powerful oxidizing agent. Okay. And there is a effect on the double bond also. For this specialist reagent, selective oxidation is done by PCC. Selective oxidation is done by what? PCC. What is PCC? Pyridinium chlorochromate. Okay. What is PCC? Pyridinium chlorochromate. Okay. Is it understood? So this is PCC, that is a selective oxidation without disturbing the double bond. It purely converts 2-ol into the ketone. Okay. Okay, here is another question. P-cresol is reacted with CHCl3 in alkaline medium to give compound A. This compound A further treated with HCN to form B. That B on hydrolysis gave chiral carboxylic acid, and structure of that carboxylic acid is, okay. So option A is like this. Option A is CH3 and here OH, and here it is CH2COOH. And option B is same benzene and CH3OH, but here it is CH2COOH. And option C is benzene CH3OH. Okay, this I am writing it here, that place is not there. So CHOH COOH. What is the answer? CHOH COOH. Okay, and D, think it is visible here. So D option is CH3OH, and here it is CHOH COOH. So these are the four options. All the four options must be visible to you. Okay. Now you can give a try and send answer to me, or pause it and check it. Okay, but I think it is okay. After you have tried, now listen to my explanation. P-cresol. What is the question? P-cresol. Actually, P-cresol is benzene with CH3 and OH. Okay. P shows that methyl group is at the para position with respect to methyl group. Okay. OH group is at para position, or methyl group is at para position with respect to OH. Then it is called P-cresol, M-cresol. Like that, there are three cresols: O-cresol, M-cresol, and P-cresol. Now here see one small ALK means alkaline medium, ALC means alcoholic medium. Okay. So every alphabet makes a lot of difference. Alkaline medium substitution will take place. ALC alcoholic medium elimination will takes place. Okay. So that's why in organic every word purpose is very important. Okay. With CHCl3. So it should strike into your mind whenever the question is about CHCl3 and you have some phenol. It is a very famous naming reaction. It is a Reiner-Teiman reaction. Okay. So there are two types of reagent. If it is CHCl3, then aldehyde will be formed, and if it is CCl4, carboxylic acid will be formed, but their position will be this one only, and it is commercially. Without this, it is called as salicylic aldehyde and salicylic acid, Reiner-Teiman reaction. Okay. So, but let us not go into in depth of that. Now, right now, what we will do? It will form aldehyde. Okay. So, at what place? At ortho with respect to OH, not with respect to methyl. That's why options are very confusing. Okay. So, this is CH3 and here OH. So here at this position it will be CHO. Okay. So up to here is it understood? Compound A. This is compound A. Okay. Now I will eliminate this, which adds HCN. Now to this reaction, to this reactant, what I have to do? I have to add HCN. Okay. So this is benzene with methyl group. This is OH with CHO, and clearly explained the reaction of HCN. Okay, it will add, it is a nucleophilic addition reaction. Hydrogen will go here, CN will go here. Okay, what will be the product? So if you study with care, then organic is very beautiful subject. CH, it is OH and CN. Okay. So to form B, this is what B. Is it understood? O is added with H and Cn will attach here. Understood? Now on acidic hydrolysis, this is to be hydrolyzed to give a chiral carboxylic acid. To give what acid? Chiral carboxylic acid. Okay. So on cyanide, there are two types of hydrolysis. Okay. Partial hydrolysis and complete hydrolysis. Cyanide and partial hydrolysis will give you amide. Cyanide and complete hydrolysis will give you carboxylic acid. So as the question is clearly mentioned about carboxylic acid, it will be complete hydrolysis. For complete hydrolysis, 2 moles of water. For 1 amide, it is only 1 mole of water. Okay. So complete hydrolysis 2 moles of water plus 2H2O. Understood? Now this only will be hydrolyzed. Methyl as it is, OH as it is. Now this C, H, H and C, sorry, this is OH na? And COOH. So which option is suitable according to us? So it is the C option. C option is correct. Okay, which is chiral carbon? This is the chiral carbon. One side it is hydrogen, another side OH, other side COH, and the fourth side is benzene ring. Is it understood why it is C option? Such a lengthy question. So many naming reaction is included, nucleophilic addition included, optical isomerism included, hydrolysis of cyanide also included. So if you are weak in at one of the point also, very difficult to score. Okay. Okay, here is another question from the ABHYAS related question, ABHYAS app related question. So try to attempt carefully. This type of question may be appearing in your next exam. That's why I am covering all topics related to that question. So if you know this answer, then you will answer only this question. If the topic related to all of that question is discussed, it will take some time, but your scoring will automatically improve. Okay. Okay, here it is related to the stability. It is the stability of carbocation basically. Now I will tell you with reasoning CH and OCH3. Okay. Anyhow, this pi bond is need to be converted into sigma bond. So this bond cleavage will takes place. The main problem is whether electron goes this side or electron goes this side is only the problem. Okay. Now let us see the first condition. If electron, pi bond electron goes on to this carbon atom, this will be plus and this will be minus. Okay. So this is going to be stable most carbocation because of the resonance. Because of what? Resonance. Okay. Now this will be minus. So that time what will happen? H plus will go this side, Br will go this side. Okay. If it goes in the other side, this is carbocation is 1 degree carbocation which is unstable. So to avoid that, this is the correct option. Why it is correct option? Is it understood? Now, if this is the case, then what will be the product? CH3 single bond CHBr OCH3. So that option is B. How to understand the cleavage? Which type of shift is to be made? I think it is clear now. Okay. Ready for the next question? Okay. Okay, here is another question. 2-chloro-2-methyl pentane on reaction with sodium methoxide in methanol gives. Okay. Option A, BrCH2, CH2, OCS3, and option B, CH3, sorry. Option A is C2H5, CH2, and CCH3, CH3OCH3. This is the first option. Second option is C2H5, CH2, C double bond CH2, CH3. Okay. Third option is C2H5, CH double bond CCH3, CH3. Okay. And fourth option I am writing, D option I am writing here. Okay. Sorry, these are not options. Okay. Option 1 is 3 only. Option 1 is 3 only, option or C only. And option B, second is A comma B. Option third is all. And option fourth is A and C. Okay, read out question carefully. So it is just like converting a multi-correct option into single correct option. Three products are given. In these three products, which are possible? Okay, 2-chloro-2-methyl pentane. 2-chloro-2-methyl pentane on reaction with sodium methoxide in methanol gives what? Okay, good. So here is the detailed answer. How to understand the question? First, it is given 2-chloro-2-methyl pentane. From here, it is 2-chloro-2-methyl pentane. Main problem is that sodium methoxide. Normally, you will find sodium hydroxide. Okay. So, just to confuse you here, NaOCH3 is given. Just OH, it is OCH3 minus. That is base only. Okay. And base can undergo substitution, base can undergo elimination, which is to be done here. See, they are not mentioned alkaline or alcoholic. Directly gave alcohol. So alcohol and base. That means it is elimination reaction. What it is? Elimination reaction. Dehydrohalogenation. Okay. Ultimately, in this presence, this will remove hydrogen, this will remove sodium, halogen. Okay. Now, it is you to decide. This chlorine will go from here itself. Okay, chlorine will go from here itself. But from where hydrogen will go? Okay, if it goes from here, this will be the double bond. Then number of side chains will be only two side chains. Okay, if it moves from here, then double bond will be here. Okay, see how many side chains are there? One, two, three. Three side chains are there. So according to the elimination rule, the alkene with the maximum number of side chain, more alkylated alkene is stable. Okay, so that's why I have removed chlorine from this side and hydrogen from this side. So what it will be, the double bond. Okay, so this is the product, it is possible. Okay, what is its name? 2-methyl pent 2-ene. What is answer? 2-methyl pent 2-ene. Okay, so the answer is only 3. Okay, or only C. Is it understood? So first option it is given as only C. That is the correct answer. Okay, ready for the next question? Here is just knowledgeable question. There is no twist. If you know it, then you will answer. If you don't know, don't go for just checking. Okay. So if you know, then answer. If you don't know, no problem. Okay. These type of questions are recently introduced by NTA because now it is conducting both NEET as well as mains, IIT mains. That's why they made a question bank. Okay. So actually this is more bio related. So but they are concentrating on the chapters which were neglected earlier, like chemistry in everyday life, polymers, carbohydrates. Okay, like this is a carbohydrate biomolecule chapter which were neglected earlier. Okay, environmental chemistry. In recent examination, it is found that more questions are coming from these chapters which never a student studies. Okay, so that's why I have extracted the questions of the more important as per the question bank. Okay, so try to answer this. Okay, answer is A. What is answer? Answer is A. This structure is like this, cysteine. Okay. So actually this you will study more focused in the biomolecule. Which molecule? Biomolecule. In the biomolecule there is a topic called as alpha amino acids. Okay, alpha amino acids. So alpha amino acid means carboxylic acid. This is the alpha carbon. Alpha carbon contains NH2. Okay, so alpha amino acid. In this one, this is the general formula and this is the group. So this group contained by the cysteine, SCYSTEINE. Very spelling is very difficult in the biology terms. Okay, so the answer is A. Is it understood? So we will go for the next question. Get ready. Okay, this is the question. Arrange the following compounds in the order of decreasing acidity. Decreasing order. Don't get carried away by the order sign. Decreasing order of acidity. Okay. You can try, or should I give you options also? Okay, I will give you options. Option A, 2 greater than 4 greater than 1 greater than 3. Option B, 1 greater than 2 greater than 3 greater than 4. Option C, 3 greater than 1 greater than 2 greater than 4. And option D, 4 greater than 3 greater than 1 greater than 2. Okay, these are the options also given. Now it will be easy for you to understand and arrange. Okay, so let's see who is correct, what is correct. So I will explain this, how to arrange them. You should know the withdrawing nature or releasing nature. Okay, let us electron withdrawing group. Okay, minus I and minus R increases acidic strength. okay, plus I and plus R decreases acidic strength and opposite to the basic strength. Only two magical sentence. Minus I and minus R increases acidic strength, plus I and plus R decreases the acidic strength. Okay. Now let us take to the chlorine. Halogens are minus I group but plus R group. Okay. But main problem with them is minus I is dominating the plus R. Okay. So that will be or which directing minus I is dominating. Okay. So deactivating. They will be deactivating because of the minus I but ortho para directing. Okay. Because of the plus R they are ortho para directing but minus I it is deactivating. Okay. So the result will be minus only. Then methyl is electron releasing group, NO2 is electron withdrawing group, and OCS3 is very activating group. Okay. OCS3 is very activating. The more withdrawing nature is shown by NO2. So once it is NO2, then it should be the highest acidic or lowest acidic. It should be the highest acidic. Okay. So the highest acidic is 3. 3 is here. So all answer will be this one only. So if you are given option, you should consume less time. Okay. Most electron withdrawing nature is shown by the NO2. So 3 is highest acid. Otherwise, you have to cross check also sometimes. So 3 greater than 1, C minus I. 2 is releasing, and most activating is anisole, that is OCS3 group. Okay. So that's why fourth will be least. More the donating tendency, less will be the acidic strength. More the withdrawing tendency, more will be the acidic strength. Okay. Is it understood how to apply the concept and what is the concept? Okay. Okay, here is question. Sodium phenoxide when heated with CO2 under pressure at 125 degrees Celsius yields a product. On acetylization produces C. And what is C? Okay. So this question is very famous compound preparation question. What is that compound? It is used by most of the humans in very difficult time. It starts with A. Very good. It is aspirin. What it is? It is aspirin, preparation of aspirin. Okay. So I will give you the stepwise procedure. Understood? First, what we should take? Sodium phenoxide. Okay. What we should take? Sodium phenoxide. This is phenyl. This is phenoxide and it is sodium phenoxide. On CO2, it directly attacks at the alpha carbon, sorry, that ortho position. Okay. And what it will form phenol with COONA. The first product is COONA. Okay. And product is acetylization. On acidification, actually on acidification this will be converted into carboxylic acid. Just now regarding this, I have explained in one of the question what is this is called as OH and COOH. It is called as salicylic acid. What it is called as salicylic acid. Now it is to be acetylization. Okay, acetylization means CH3CO acetyl group and it is acetylization. Okay, on acetylation produces C. So where it should go? It will go and replace this with hydrogen. One hydrogen will come here and it will go at this group. Okay. Otherwise, I will draw the structure clearly. C double bond O, C double bond O, CH3. Okay. Now, this hydrogen, I will clearly explain here. This hydrogen will come here and this CH3CO group will go and attach here. Okay. So what will be the product? COOH is retained at the same position and here oxygen, and what is this? At oxygen and C double bond O and CH3. Okay. This is the aspirin. What it is? Aspirin. Actually it is acetyl salicylate. What it is called as acetyl salicylate is common chemical name and commercial name is aspirin. Very, very important. Definitely it is going to give you good marks if you understand it carefully. Okay, so try to practice this question and this mechanism, these steps 2 to 3 times. Okay, next wonderful question. Phenol is heated with solution of a mixture of KBr and KBrO3. The major product obtained in this reaction is. Okay, so let's see what we will be able to answer or not. Okay, good replies are coming. Okay, this is question is a rare combination of inorganic and organic concept. Actually, in halogen compound KBr plus KBrO3 on reaction in aqueous medium produces Br2. Okay, plus KOH. So that Br2 react with the phenol and it gets substituted at all places. What are the places? This OH is actually ortho-para directing. All ortho position and all para positions are occupied. So D option in our question, which option is correct? D option is correct. Okay. Okay. Final question, but very, very important, very, very typical question. Find X. In this reaction, what you have to do? You have to find X. The reaction taking place in 2 steps. After completing both the steps, you should be able to identify what is the product. Okay. So complete the both step. After NBS in presence of H nu, what is the product? And after that, when it is treated with H2O oblique K2CO3, what is the arrangement taking place? More stable product you should give. What you should give? More stable product. Okay, let's see. Will you be able to do it or not? Okay, try. First reagent is NBS H nu. Second reagent is K2CO3 H2O. What is X? All structures are given to you. Okay, now listen. See here, NBS is a specialist reagent for allylic bromination. Which bromination? Allylic bromination. Allylic means double bond carbon, adjacent carbon. This is also possible. This is also possible. Okay, but there will be 2 allylic carbons. Here also possible and here also possible. But where to substitute is only the problematic. Okay. Now, which one you suggest? This one is more stable. Why? Because there is a steric hindrance. When bromine gets substituted, there will be repulsion between this bromine and this methyl group. That bulky group is given here. Actually, this plus sign means C, CS3, CS3 and CS3. Okay. So it feels suffocated when it is substituted here and it can be peacefully stay at this place. So the major product when reacted with NBS in presence of H nu, the substitution will take place at this. Okay, first product. After the first step, this is the product. And instead of KOH, he has used to confuse you K2CO3. This is also alkaline, basic medium. In that, what it will takes place, substitution will takes place. Okay, K and Br will be eliminated and OH will be substituted. What will be substituted? OH will be substituted. This double bond remain as it is, and this is the OH. So accordingly, you can select the option. Had a wonderful questions. So like these questions, I will be selecting the questions from the NTA question bank from the ABHYAS app, and I will be making you aware of the latest pattern question. Okay.